Second generation programming languages. A little bit of backstory first. These are called assembly languages, and they were originated in the 1940s, just as the newer versions of computers were being developed. So this is not an ENIAC style original computer. It's a little bit after that, introduced with the Flowmatic language for ENIAC and the computers thereafter. One of the big things that happened to cause this was that the transistor was invented in 1947 by William Shockley and Co. Now this meant that a computer could become a lot smaller, and you see in the diagram there, the computer, instead of being the size of a room, is only the size of a small cabinet. This meant that they're about 90% smaller than they used to be, and also therefore more powerful. And that's what I've just said. Okay, second generation language was developed in the 1940s by Grace Hopper. This picture is Grace Hopper, as you see. They used assembly code rather than binary code, consisting of alphabets and mnemonics. A mnemonic is a short word to describe a command. This allowed for much easier programming than first generation languages and limited quite significantly mistakes that could be made. When you're coding in a first generation language, you're coding the actual binary that the computer will process, which could lead to mistakes far more easily. What happens with assemblers is you get a short bunch of phrases that are more easy to understand, considerably more easy to understand than first generation languages. Look, for example, here. MOV is a mnemonic, EAX is a memory byte, EBX is another location. So move memory location A to memory location B is the first design there. Beg your pardon. And so you get a couple of other examples there of mnemonics and instructions, and you can see from the code comments what is expected to be being done. So the bottom one, move DS to DX, move the contents of memory DS, move the contents of DX into the register at DS. So you can see why it would take less programming, would require less programming and would be less likely to cause errors than a first generation language. Here's another example. Add 12,8, so this would be what you and I would see as 12 plus 8. And the answer you'd expect would be 20. Okay, so now we have an assembler, and it's really important you understand the word assembler. This is the second generation language, and this is how code that was written in a 2GL gets converted into machine language to be executed. It uses an assembler, turns the instructions into machine code. This allows for easier programming and limited mistakes as compared to, as I said, first generation languages. So at the top of the diagram you see a whole bunch of second generation coding language, which then runs through the assembler, which then gets converted into ones and zeros to be executed by the CPU as machine language. So if you look at the diagram now, you'll see that there at the bottom you start with the hardware. You have ones and zeros as machine language, and assembly language at the second level. The higher level languages are above that, and they use something different to an assembler. They use a compiler, which gives you a bit of an example of the differences between generations of programming languages. Computers using 2GLs were in the 1950s and 60s. They were small than first generation computers. As you see, again, the computer's quite small. This is because the technology used was transistors instead of vacuum tubes. We started to use magnetic disks, and second generation languages made them easier to program. Now, second generation languages shouldn't be seen as being particularly easy. You had to know a lot of mnemonics and understand a lot of command line interface instruction, which is not as user friendly as third generation languages or even fourth generation languages. But they're certainly easier than first generation languages. Thank you for watching.